Hello everyone, this video is going to talk about the water cooling system for the Hybrid Flame Analyzer. Currently we're just using water from the sink. It runs through the system and then distributes back into the sink drain. I tried doing a recirculating system, but that needs to be cooled, and the cooling, the heat sink I was using overheated, so the attempt kind of failed. But currently what we have is you have water coming out of the tap, comes through this rather large flow meter or rotometer for water. We want about 10 gallons an hour to be running. That comes out and goes through this 1/8 inch OD copper tube. The reason you do that is because the 1/8 inch, this is the same size tubing that's around the burner nozzle. So the burner nozzle was having a lot of drag, and so I was getting leaks in the water cooling system. So I wanted any kind of fittings that were going to break or start to leak to be the ones on the rotometer or connecting to the sink itself rather than over on the instrument. So that's why this little piece of tubing here that's just kind of floating for no reason is there, is to make the drag that you're going to get on the burner, or the increase in pressure in the system, is going to occur here rather than at the burner nozzle itself. So the water comes out of the sink, through the flow meter, through the kind of pressure increasing tube, up along the ceiling, over, down, and back around, and then comes up and goes around the base of the burner and then around the burner tip. It enters back here, it enters on this side, goes around the burner itself, and then comes out on this side. Then it goes up and cools the exhaust, we'll call it the exhaust nozzle or the exhaust kind of vent. So this has a taped and pipe clamp connection to the exhaust ducting, and so if this isn't cooled at the high flow rates for the turbulent flames, there's too much heat because you're running 4 to 8 times as much fuel as for the laminar cases. So the turbulent cases, you're producing much more heat, so this whole system starts to overheat, and you can hear the glue starting to disintegrate or degrade if you don't cool it. So we have the cooling, then it comes out and runs back to the sink after working on this. So if you wanted to improve it, you could theoretically make a recirculating system so that you weren't just wasting the water, but you need a heat sink there so the water doesn't heat up as you run the tests. But this is just about how the water is currently set up. So I hope you found this useful, and have a good day. Oh, I forgot to, if you want to change the nozzles, so we have this nozzle, which is the turbulent nozzle. We have this nozzle, which is the laminar nozzle, also has water cooling around it, and this nozzle, which is for the calibration of the flow feeder. So this is a 1/4 inch, a set of 1/4 inch tubes. What's in there now is 1/8 inch tubing, OD. So we talk about OD because we're using pressure fittings. So there are some swage lock connections here. You have a 1/4 inch to 1/8 inch fitting here. You have some connectors so that the tubing is a little longer than it has to be because it wraps around the burner, so that you're not getting a bias towards the back because your tubing is connected here. So if your tubing is a little too long or too short, it'll either pull or push the burner in one direction or the other. So I kept it long to make it loose. So when you switch out the burners, you want to empty the water line of the water so that it doesn't leak out everywhere when you disconnect the fittings. So to do that, I've been disconnecting this line and then using pressurizing the line using this kind of, what's it called, a dust cleaning thingy. So I just put a 3/8 inch swage lock fitting on it. connected here, and the reason I use this rather than one of the air tanks is because this leaks. So it leaks here, so you don't have too much pressure build up in the water line. So you get just enough pressure, pushes the water out nice and easy, but doesn't blow the fittings or the connections. So you don't want to put on too much pressure in these lines or they'll blow off. So once again, if you want to improve that, I'm not saying this is the best way, it's just the way that I'm doing it currently. So you can improve it, or obviously this is what I'm doing now. You need to make sure that it's safe for yourself. This is not UL tested or comes with no guarantees that it is safe and appropriate. So I hope you found this useful, and have a good day.